Hi, I'm Bob. Today we will explore the third model that describes the oligopoly firm's behavior. It is called the Bertrand model. Let's take a look at the assumptions of the Bertrand model. First, there are only two firms in the market. Second, we assume that the firm sets its price instead of quantity. Third, the two firms set their prices simultaneously. Fourth, we assume that the market lasts for only one period. Each firm chooses its price only once. Fifth, we assume that all firms are identical. They have the same production cost, and they produce identical products. The marginal cost and average cost are a constant C for all firms. Whether the firms produce identical products or differentiated products leads to very different equilibrium price and quantity. I will discuss the case of differentiated products later. 6. They have complete information, which means they know each other's strategies and profits. The payoff function or the profit function is the common knowledge. We see that the only difference in the assumptions between the Bertrand model and the Cournot model is the variable the firm can choose to maximize its profit. The firms choose prices in the Bertrand model, but the firms choose quantities of output in the Cournot model. Under these assumptions, we can show that the Bertrand equilibrium price equals the firm's marginal cost and the firms earn zero profit. We use ice cream firms as an example. Suppose there are only two ice cream firms in the local market. Assume that both firms' marginal cost is $1 per ice cream cone, and both firms set a price of $2 per ice cream cone. They share the market, and each firm makes half the sales. However, this is not a stable equilibrium. If a firm slightly undercuts its rival's price by charging $1.9 instead of $2, it will capture the entire market, because consumers could not tell the difference between the two firms' products and will purchase from the firm that offers a lower price. Both firms are aware of it, and they will undercut each other's prices until the price reaches their marginal cost. This is the first case, when the prices set by the firms are equal to each other and higher than their marginal cost. Both firms have an incentive to lower their prices until they are equal to the marginal cost. In case 2, if at first Firm 1 sets a price higher than Firm 2's price, Firm 1 has an incentive to reduce its price below Firm 2's price. Firm 2 knows that, and it will also reduce its price until both firms set a price equal to their marginal cost. In the third situation, both firms set a price equal to the marginal cost, and no firm has an incentive to deviate from it. So the Bertrand equilibrium is for both firms set a price equal to the marginal cost, the same as the competitive equilibrium. We can also find the Bertrand equilibrium by using the best response functions for both firms. For Firm 1, we know that it will not set a price lower than the average cost C, regardless of the other firm's price. The average cost is the same as the marginal cost in our example. For the price above the marginal cost C, Firm 1's best response depends on Firm 2's price. It will set a price a little bit lower than Firm 2's price. So its best response curve lies slightly above the 45-degree line. That is to say, Firm 1 undercuts its rival's price as long as its price remains above the marginal cost. Similarly, the best response curve for Firm 2 lies slightly below the 45-degree line. The two best response curves intersect at point E. It is the Bertrand equilibrium in which both firms charge the marginal cost C. Next, we consider the Bertrand equilibrium with differentiated products. Many economists believe that price setting models are more plausible than quantity setting models when goods are differentiated. In the differentiated goods Bertrand model, one firm can charge more than another for the differentiated product without losing all its sales. For example, Coke's Fanta and Pepsi's Mirinda are similar but not identical products to many consumers. They prefer one to the other. If the price of Fanta were to fall slightly relative to that of Mirinda, most consumers who prefer Mirinda to Fanta would not switch. Thus, neither firm has to keep undercutting its rival's price to avoid losing all its sales, like in the identical product Bertrand model. We assume that the demand curve Firm 1 faces is Q1 equals A minus B times P1 plus D times P2. The demand Firm 2 faces is Q2 equals A minus B times P2 plus D times P1. A, B, and D are positive. From the demand functions, we know that the two firms' products are substitutes, but they are not identical. The demand for a firm's product decreases if its own price increases, or the price of its rival's product decreases. We use the constant marginal and average cost function. Firm 1's profit is equal to total revenue minus total cost. We plug in the quantities expression and have a profit function containing prices. The firm chooses a price to maximize its profit. The first order condition implies that Firm 1's profit maximizing price depends on the other firm's price. This is Firm 1's best response function. If its rival sets a higher price, it should raise its price. Similarly, we can derive Firm 2's best response function. We can draw the two best response curves. The intersection of the best response curves is the Bertrand equilibrium for differentiated products. In this Bertrand equilibrium, each firm sets its best response price given the price the other firm is charging. It is a mutual best response. Neither firm has an incentive to deviate from it because neither firm can increase its profit by doing so. Notice that the condition B is greater than D over 2 is to ensure that Firm 1's best response curve is steeper than Firm 2's, and therefore the curves intersect, and the equilibrium price is positive. Thank you for watching this video and subscribing to my YouTube channel. See you next time.